Okay, week 5, it's all about the dplyr package. This is really one of the core packages in the tidyverse suite, and it's a fantastically flexible and powerful package that we'll get some introduction to. Okay, so a common action in statistical analysis or data analysis of any sort, data exploration, is this idea of split up, applying and combining. We split up a data set into subunits or pieces. We apply a function to these pieces, and then we combine the output and examine the results. Examples of this might be calculating the mean response by treatment. So we might have treatment A, B, and C with multiple observations, and then we want to know what the mean of each one of those treatments A, B, and C are. We might think about running an ANOVA on numerous response variables and then compiling that output together. We might think about calculating total precip from weather data by month or year, or both month and year. So, you know, this idea based on experimental design or these identifying variables, if we use the reshape language, and applying a function or a set of functions and then combining them. So it's very, very common that we do this in a statistical framework. So dplyr offers a streamlined and simplified approach for writing for loops. And that's really, we haven't talked too much about for loops yet, but you know, they're really powerful things and just helps with some of the housekeeping and setting these up. So plyr is the first version of this, and it's more flexible in the sense that you can split, apply, and combine, split up data frames, you can split up lists or arrays, both as inputs and outputs. Plyr can be a little bit cumbersome to set up some code and execute. If you're wanting to do things with list, plyr is still a perfectly good option. But increasingly, the majority, the masses of our users use data frames, and that's, you know, really thinking about data in a two-dimensional framework where we've got rows as observations and columns as variables. Very, very common to store data that way. And so dplyr, or plyr, you know, this plyr that's specific for data frames as inputs and outputs. And this is really where a lot of the development, a lot of the energy in our studio and the Hadley Wickham team of scientists, data scientists are spending their effort. And you see a lot of this increasing just really in the last 3-4 years. It's been quite interesting to see where they're taking this. So both plyr and dplyr are supported, but again, dplyr is really the go-to package, and there's a lot of examples and help surrounded around dplyr. Okay, so let's get into this a little bit and give you a little bit of a flavor for what this package can do. And so again, we're going to load tidyverse, which has the package dplyr in here. Okay, so here's the package dplyr, and again, my R, I need to update this, but I haven't done this yet. We're also going to load reshape, just as we worked with last week. Okay, and go back to this boring old MPG data set that you all have familiarity with. And again, this is a Tibble, you know, it's a miles per gallon data set, looking at by different manufacturers and models, engine displacements, years, etc. And our response variables of interest, at least for here, the city and highway miles per gallon. We're going to simplify our data freight, simplify this data set and cohorse it to a data frame. I'm using this data.frame. It basically forces it from a Tibble back into a data frame. And you can see it's no longer a Tibble, it's a data frame with 6 variables and 234 observations. So again, we just reduce five of the variables here, just for the sake of simplicity. So dplyr has a set of functions that are mostly redundant with some base R functions, but provide kind of a common framework and language or just consistency in terms of data manipulation. One of the things about R is that there's a lot of these kind of idiosyncrasies that happen. It's been a language that was built, over time, and it's not perfectly coherent or consistent. And so a lot of the kind of the tidyverse development is trying to step back from a global perspective, and everything in that all the packages that encompass that tidyverse all kind of come to the table using a similar syntax, similar approach in terms of how arguments are input and et cetera, et cetera. So here are some of the functions in dplyr. I'm sure this isn't an exhaustive list, but these are some of the big ones. And all of this, of course, can be found in this dplyr.tidyverse.org URL, which is actively updated, and it changes. I mean, even as we teach this course from year to year, there's definitely a lot of change that happens in different development that we see year after year, and it's part of one of the reasons that this course is so fun to teach, because it just keeps us updated in terms of all the developments. Okay, so filtering, slicing, arrange, select, rename, distinct, mutate, transmute, summarizing, sample and sample fraction. Okay, these are different things. We're not going to talk about all these here, but so filtering is really just, it's another way to index, right? It's maybe a little bit more intuitive or a little bit helpful. So here we're going to take filter, that's the function, we're going to apply it to our data frame df. And then our kind of conditional statement here is manufacture double equals forward. And remember, when we're in R, we don't use an equal sign. Equal sign is basically assign something, so it's that gets at. But when we have a double equals in R, that's a truly mean that's equivalent to actually equals. And so if we ran this code, this is returning in our data frame every observation where the manufacturer equals forward. That is equivalent to indexing. And just, you can look at these a little bit different, but here in indexing, we use these brackets to kind of, and this is quite flexible too, of course, in terms of what we can do with this. But here we're saying in data frame, all data frame manufacturers that equal forward in all columns return this. So these things provide identical output. Okay, and here, interestingly, if you'll notice, filter does this row indexing 1 through 25, whereas if you actually use kind of the base R index, it maintains that original row index where those rows were in that original data frame df. Okay, so that's not too important of an observation, but just something to note. Okay, again, we can do it based on model, Mustang, or city miles per gallon that equal 14. So all the city mile per gallons that equal 14, or that are less than 11. So this is city less than 11, or less than or greater, or less than or equal to 11 rather. And so there's a lot that are actually 11s. And then, so, this is essentially indexing just a different way. And some people say, well, I already know how to do that. I don't need another way to do it. But, it's just kind of good to get a little bit of exposure to do multiple conditions. Here, filter Honda, comma, highway greater than 30. So these are actually two different conditional statements, one that manufacturer equals Honda and one that highway MPG is greater than 30. Okay, so we just use that with a conditional. So we can return that. that is, you know, synonymous with using this ampersand, which is a Boolean operator, just says and, okay? And if we were going to do this in, you know, indexing, it would take a little bit more time to kind of write this out, okay? But this might be a little bit of a shorthand. Filter manufacturer equals that, highway equals that. You can also, this is, again, a Boolean operator of ampersand, and here this is one of or. So instead of both of these conditions need to be met, it's one of these conditions need to be met. So this is both of the conditions, and this is one of the conditions. You can see that with the or as an operator, there's a lot more. So it's exhaustive of all the Honda manufacturers, and then all of the highway miles per gallon that are greater than 30. Again, reminder, your Boolean operators here that you can use in filter, okay? All right, so filters is sorting based on a condition, selecting observations or rows based on conditions. And we can use a range, which is a sorting row. So, you know, sort is taken in base R and order is taken in base R. So they use this word arrange, which is a little bit of an awkward word, but it's basically a sorting function. And I actually find that arrange is a lot more intuitive and easier to use than sorting and ordering in R, which can be kind of complicated. And I always find myself Googling kind of seemingly a simple little problem about like how to sort on two conditions or something, or two observations. So we go back, we go back to our MPG data set. Here's our original data set with all the variables. And then we can say arrange, which is again sorting. We're going to apply this function to MPG, the data frame or the tibble here. And we're going to sort by city. Okay, so again, that's city miles per gallon. Here it sorts it from smallest to largest by default. If we want to reverse that and sort that from largest to smallest, we use this DESC, descend, which is what it stands for. So we just put that as an argument, DESC city. And then here it's sorting from where the city is, the largest values come first, okay? So that's just a simple sorting function, which, and again, you can do first by city and then by manufacturer, okay? So multiple conditions or whatever. So here we have city, and then within city manufacturer, so Dodge, and then Jeep, city is 11, then Chevrolet, then Dodge, et cetera, et cetera. So this is just, in my opinion, an easier way than using the default function of order in R. So if that's helpful. All right, I'm kind of breezing through these fairly quick because I just don't think there's a great need to spend a lot of time on this. Just, it's good to have some familiarity. So selecting is essentially the same as filter, but instead of applying conditions and filtering out observations, you're filtering out variables. You're selecting variables of interest. Okay, so again, here's our mile per gallon tibble, and we're going to select miles per gallon, and we're going to actually select the model, the year, the cylinder, and the transmission. So model, year, cylinder, transmission. Okay, of course we're all lazy beasts at heart, and so there are shortcuts. So we can say model : to highway. So here's model to highway. So it's going to select all variables in there. There's model to highway. And we can omit variables easily just with this minus sign. Okay, so this is a little bit, with indexing, we often use a equals exclamation point, or exclamation point often means, omit that. So here we go back to our MPG tibble. It's going to say everything except from transmission to city. So it's going to omit these three variables here. Transmission to city is gone now. So, okay, so that's select. So you can opt in, you can use You can also use, I guess I should have done this, but you can do things like select, 1 through 5. And here's the first 5 variables, right? So, or select comma 1 through 5, 8. So there's lots of different ways that you can, I usually use numbers because I find it's a lot easier than using variable names, but okay. Just think, this is a very, very nice, just a function I use all the time. I think it's it helps, it's similar to unique. There's a unique function in base R. Distinct is nice because it works. It's very flexible in terms of how it works. So all it's going to do is return the unique observation. So here we're saying distinct applied to data frame, and then what are all the manufacturers that have unique observations, okay? And so here we are, and this is nice when you bring in data and just try to see, like, you can do, as an example, structure df, and here's manufacturer. It's a character, but you can't really see what's all here. If you just do the same thing with distinct manufacturer, you can find out really, really quickly. You've got 15 total types of manufacturers, and then it provides a list for you. But what's also nice is that it works on continuous variables too, so you don't have to like coerce things into a factor. If it's a discrete number or integer, you don't have to coerce it to a factor. It's all done behind the scenes or in R. And so here is the distinct city. And you can see that because it's actually, well, I don't know if it's coercing into a character or factor, but one of the two. And because of that, it's actually a little bit out of order. This is how it's actually encountered it in the data set. So it's not sorting it from, but you could easily sort it and do that as well. Okay. And you can also, not surprisingly, works on combinations of variable classes, so multiple variables. So here, and then in all of dplyr, these functions, if just a comma, manufacturer and city, right? So you can just add arguments or add additional conditions just with a simple comma, okay? And so here are all the unique or distinct manufacturer by city MPG combinations. So in case that's important to you, but you could see. All right, so those are kind of like what I might call indexing or simple things. Really the true value in some ways of dplyr is to summarize and mutate. And summarize, and it doesn't matter if you use the English or the British or New Zealand version of summarize. With the Z or an S, they're the same and implemented the same in dplyr. Hadley Wickham is originally from New Zealand, so he's partial to the S, which is fine. But these are related aggregation tools that provide similar functionality to Reshape. So Reshape does one thing, but I would argue very eloquently, dplyr does a lot of things, but it's a little bit clunkier, and that's why I still think it's important. Just I still use Reshape. I use dplyr. It just depends on the situation. Summarize creates a new data frame with aggregated output. So think of summarize as kind of all in one step of Reshape. It's just a single essentially line of code that you can group by, or you can tell it how to break up the data, tell R how to break up the data into subunits or pieces, and then aggregate based on that. And then mutate actually creates new variables and then appends it to the existing data frame. And that's a little bit harder to understand. We'll show you that in here in just a second. Okay, so All right, so, and from here on out, the code's going to get a teeny bit more complicated. So here we've got summarize. We're going to apply that to our data frame. We're going to create a new variable that's called mean.city. We can call it anything we want. And the variable is going to be the mean of city. And then we're also creating a new variable mean.highway. And then that is the function of mean applied to highway. So basically we're taking the mean of all these observations and we're calling them these things, okay? Mean.city, mean.highway, okay? And so this is across our, whatever our, our dimensions, we've got 234 observations. So across all 234 observations, the mean city miles per gallon is 16.8, 16.9, and mean highway is 23.4. So, you know, that's great. And we can do this with reshape, of course, too. But we use group by, and the real power of dplyr and plyr and reshape comes with the ability to group functions into subunits, right? So in Excel, of course, it's easy to go in and just say, what's the mean of, you know, these 234 observations? But what happens when we need to break those observations down by manufacturer, the 15 manufacturers that we have, or all the makes of the vehicle, or this versus that, you know, maybe combinations of manufacturers and models, etc. There's a lot that we can break things down by. And so in now this is a little bit different framework than reshape, right? But what dplyr uses is this group by function, and that is, again, kind of intuitively, you're grouping things by a specified variable, right? So here I'm just creating an R object called by.manufacturer. I'm applying this group by function to it. So I'm applying group by df manufacturer, okay? And so when I do that and I return the R object, now it says it's a tibble, and then it says groups manufacturer, and there's 15 of them. So you know exactly how many are there. Now compare this, if we just put in MPG, it just says tibble, right? But if we put in group by MPG by manufacturer, and we run this, it's the same thing. Nothing has really changed. It's still 234 observations by 11 variables, 234 observations. But here with the group by, you can see that there's this additional kind of characterization of the data, or an assigning of groups based by manufacturer. Okay, so but other than that, it's the same. All right, for the sake of this code, I'm going to go back and change this to df like we had. Okay, and so now I'm going to run that same code that we ran up here, summarize df. And instead of applying it to a data frame, we're applying it to this by manufacturer, which is again a tibble with a pre-assigned set of groups. So we're going to summarize this by.manufacturer, mean city and mean highway. All this stuff stays the same. And then of course when we do this, then the real true value of dplyr and the power that you can do, and the efficiency and speed, it's a tibble with 15 observations and 15 observations and 3 variables. And so here again we do this by manufacturer. Okay, we can do things, not surprisingly, your mind's probably already going there, but we can do things like, for example, go up here to the group by and say manufacturer model, and then we've got, you know, 15 times whatever, there's 38 unique combinations, and we can summarize here, and now there's, you know, these 10 plus 28 more, so 38 total. So just again, this is, you can think about this as if we think about reshape and what we talked about last week, first we would melt, and then we would define the group by, again, by saying something like manufacturer plus model by variable, right? And then we'd have to assign the function. So it's just a little different. You know, this would be part of your cast call, right? But here it's kind of integrated, and it's just a little different in terms of the same pieces are there, but the kind of the approach is different. All right. Now, if we imagine, you know, we've got two variables here, response variables, or what reshape would call measured variables, mean.city, mean highway. And again, this is my kind of dplyr will get here, and they'll get there eventually, but they're, in my opinion, they're just not here yet in terms of making it as easy and convenient and elegant as reshape does. They've got different wrappers that allow you to, instead of having to find each variable name, you can do things like summarize all, summarize if, summarize that. I've learned this year that they are actually getting rid of these, and so presumably they'll still work, but they're replacing it with this kind of this more universal across, so you can go apply a suite of functions or a function across multiple variables. So there's a lot of different things, but let's just talk real quick about summarize all, if, and at. Again, I'm going to do this group by manufacturer, and then I'm going to do summarize if by manufacturer, and then here's the is numeric. So summarize if, we're applying that function to by manufacturer, which is this tibble, this grouped tibble. And then the if is, does it satisfy the requirement is dot numeric, which is an R function that basically it's a logical, is it numeric or is it not? And then we're going to apply the mean to that. So again, this becomes a little bit complicated, but here, if we go back to this by manufacturer, we can see we've got a character, a year, which is actually an integer, which it probably should be a factor. It's not really a response variable, but that's how R is reading it in this sense. So it's going to take this, it's going to omit these three characters, and it's going to take the year, the city, which is an integer, and the highway, which is an integer, and it's going to return those. Okay. So again, it's summarize if. And we can also do multiple functions with this list function. So we create a list in reshape. Again, it was using the C for concatenate, but here in dplyr it's list. So there's just some differences here, and I hate to kind of, you know, all these different ways to kind of do the same thing. You have to figure out what's best for you and what you prefer, etc. A lot of these nuances for me are hard to remember, and so again, this is another reason why reshape is just sweet and simple. Okay, so we can do things and like this, but again, here's another piece of a teeny bit of clunkiness with dplyr, where now we've got year and it's function one, city function one, which is the mean, and then we've got function two, so it doesn't actually take these names and kind of automatically assign the variable name with it, which is another really nice thing that reshape does. Okay, and so again, having not given this the full attention I probably should have, but I'll at some point I'll wait until dplyr comes out and it's all, you know, perfectly streamlined and consistent, and then I'll probably at that point sadly stop using reshape. But until that time, so here they're using this across to try to replace these, you know, summarize all, if, and at, and here we can say summarize across city and highway. But again, like I'll just show you this tibble again. When I was first using with across, I couldn't. So let's just take a tiny minute and look at this call we just ran. Summarize again. It's our grouping by it's our grouped tibble by manufacturer. We're going to say across city and highway as variables, and then apply the mean. And so that's what it's really done here. Okay. And if we run this, we can see. But I tried earlier when I was kind of putting this code together, and if you do across variables 5 and 6, which are what the variables are in the tibble, there's 6 variables in 5 and 6, and you just want to apply the mean. So you would think that these two are synonymous, but you run this and you get an error message. So it's just a little bit, you know, it's again, this happens to me. I'm like, oh, this is a new way in dplyr I can do this, and and then it's just not as kind of flexible and as nice as reshape is. And so again, I'll always go back to that, but that's just an old dog talking. So do whatever feels right for you. Okay, let's move on to, so, you know, we talked about all the stuff that Summarize can do last week in reshape. You know, kind of a redundant set of functionality, but still good to know about. All right. Mutate, creating new variables. Okay, so let's look at, again, remind you what df is. This is our just the first 6 observations. And we can create new variables in Mutate by just saying, here's a ratio of city to highway. So we're basically taking the city and dividing by the highway. And when we do that, let's move up to the top here. We've got across each one of these observations, it's taking basically the ratio of city versus highway. Okay. But again, this isn't really, we can do that easily without Mutate. We can do that just with, you know, basically by explicitly saying it's, you know, we can do this by saying df ratio df city versus df highway, right? And that will actually, when we do that, does the same thing what Mutate just did. So it takes, but again, the value and the true power of Mutate and Summarize are when we have this grouping capability. So here we're going to run, let me go, probably, well, that's fine. I'm going to go back up, and when we apply Mutate by manufacturer, it's going to give us the mean.city. So we're going to apply Mutate to our grouped tibble, and we're asking for the mean.city. Okay, and so let's look what happens now. Now, as opposed to before where it was applying on a per observation basis, Mutate is a little different where it's grouping this since by manufacturer. So it basically takes the mean of the city highway miles per gallon and reports that for each one. Okay, and so again, if we well, let's see if we can call that X, for example, and then say X, show us say the first 20 observations. And so now for the mean, well, let's make it 30 just to, no, it's not gonna let me do that. Let's say first 20 observations. Okay. So here, what it's done, it's taken the mean for each grouping. So Audi city mean is 17.6. And then when we get to Chevrolet, a new manufacturer, it takes the mean, which it's, this isn't all the observations, but this is 15 is the mean across all the Chevrolet miles per gallon. Okay, so we can note the differences between mutate and summarize here. So it's the exact same call, mutate by manufacturer, mean city. So again, this is what we just looked at, 17.6 is the mean for the Audi. And then if we summarize by manufacturer, mean city, so it's the exact same call here, except one's mutate and one's summarize. If we run the summarize, it actually restructures the data. And so now there's just 15 observations. It strips everything else away. But mutate's really nice because it retains the entire data set and then basically just appends the new data that you've created to another variable in your data frame, okay? And so this might not be perfect for everything, right? But we can imagine like a scenario where we would do something like, say we call this XX. And so now we've got, if we want to return XX, we can see, but now what we want to do is we want to create XX delta, and this is just XX city minus XX mean dot city, right? And so now for each observation, we can basically calculate a delta between what, what's the departure from the mean in some ways, or what's the difference between this observation and the mean across groups. And of course, since this is a grouped by mutate, it's going to differ. The mean is for each manufacturer, right? It's not a grand mean across all observations. So we can do this a lot of different ways, but this is a helpful function in lots of different ways. Okay. I'm gonna stop there, and we're going to go into chaining or piping next.